Good morning, grade 8. We are now in the giving of examples, the unlocking of difficulties, right? As promised, I will give you a lot of examples with regards to how can we get the number of protons, neutrons, and electrons, and how can we have the electron configuration of a particular element. So, okay. So let's start with how can we get the number of protons, neutrons, and electrons? Based on our discussion, the formula in getting the protons is equal to the atomic number. Simple. Okay. The formula in getting the electrons, okay, this is actually the atomic number minus the charge if it is an isotope, or if it is a cation or an ion. Okay. How about neutrons, or the neutral, or the particle which don't have actually charges? This is the mass number, okay, mass number minus the atomic number, because mass number is greater than the atomic number. Then you can get actually your neutrons. So let's have this example. Let me share my my periodic table of elements. Hope you have also your own periodic table. Please get your periodic table of elements. Okay, let's have fluorine, for example. Okay, the atomic mass of fluorine is 19. Can you see it there? Okay, how can we actually write it over? So let's have, okay, let me have the, okay, let's have the whiteboard. Okay, according to my periodic table of elements, the atomic mass of fluorine, okay, fluorine has an atomic mass of 19. So mass should be in the upper right, upper left. Okay, this is 19. Okay, and the atomic number of fluorine is 9. It is actually the 9th element in the periodic table of elements. So because this is 9, we will actually put 9 on the lower left corner of the symbol or the element. So we have now the atomic mass of fluorine and the atomic number of fluorine. So we can now have the protons. We can now have the protons, okay, P, which is equal to the atomic number. Okay, so this is 9. We have 9 protons. Okay, how about the neutrons? Neutrons is equal to, what is the formula in getting your neutrons? Formula with neutrons? Formula of neutrons? This is mass number minus atomic number. So again, the mass number here, we're going to look at it. This is 19, okay, minus 9, okay? That is actually your neutrons. We have 10 neutrons. How about electrons? Okay, electrons is equal to, what is the formula in getting your electrons? This is the atomic number, okay? Atomic number minus the charge, okay? Atomic number is equal to 9, okay? Minus, there is no charges here because this is stable, okay? This is an element in stable state, meaning to say it is not actually charged either positively or negatively. So this is in stable state. So meaning to say this is 0 is equal to 9. So if you're going to check on the protons of Fluorine 19, we have, okay, 9 protons, 10 neutrons, and 9 electrons. How about if we will change the fluorine into fluorine a cation. You will change fluorine into cation. We have fluorine fluoride, okay, with a cation 2 plus. So it is now isotope. It becomes now what? A cation. Let's check if the number of protons, neutrons, and electrons are still the same. Okay, we have protons is always equal to the atomic number, okay, which is 9. Neutrons is always equal to, again, neutrons. So the higher number first, this is the atomic mass, okay, minus the atomic number. So it will become 10. So we have the neutrons here is 10. How about the electrons? Electrons is equal to atomic number, okay, minus the charge, okay, which is positive 2, correct? What will be the result? What would be the result? Since this is positive, okay, minus and a minus sign, this is actually the difference between 9 and 2. Okay, so this is 7. Okay, so we have now protons is 9. Okay, neutrons still the same, 10. But the number of electrons here is actually lower than the protons because this is a cation. When you say cation, it is actually positively charged. This is the reason behind. How about if we will actually use or we will change this into an ion? What will happen to the element? Okay, what will happen to our protons, neutrons, and electrons? Okay, P plus is equal to the same 9 because it is equal to the atomic number. Neutrons here, always atomic mass minus atomic number, 10. How about electrons? Electrons here is atomic number minus the charge. Okay? Since this is all negative, it will become addition. Okay? The summary of or the sum of 9 and 2. Okay, we have 11. So in an ion, it has more electrons, okay, more electrons than protons because this is negatively charged. Okay. Do you want another example? Do you want more examples? Everybody, are you still with me? Okay. Let's have another example. How about, let me check on my periodic table. How about sodium? Okay, sodium. Sodium has an atomic mass. Let's have sodium. Sodium has an atomic mass of 22 point. This is the atomic mass of sodium, 22.99. Okay. If you are actually not given the atomic mass of a particular element, you use the what? The stable ones. So what is the most stable sodium here? Sodium 23. That's the most stable because this is actually the nearest, okay, the nearest number of atomic mass. Okay, go to the nearest, you need to round it off. Okay, if it is not given, if the atomic mass is not given. So this is 23. That's the most stable, okay, in sodium family. Next is the atomic number. What is the atomic number of sodium? Sodium belongs to, or the 11th. Okay, this is the 11th element in the periodic table. So this is 11. We have sodium 23. Let's take a look at sodium 23. Okay. Protons is always equal to the atomic number. So this is 11, correct? How about neutrons is equal to the atomic mass, higher minus lower, the atomic mass minus the atomic number. So 23 minus 11, what is the answer? 23 minus 11, we have, are you still with me? Grade 8, are you still with me?
12.
All right, 12, correct. So this is 12. We have 12 neutrons. How about electrons? Electrons is equal to atomic number minus charge. Charge here, we don't have charge because this is stable. Okay, it is always equal to 0 if it is not actually charged. Okay, if it is not charged negatively or positively. So this is equal to 11. So we have 11 protons, okay, 12 neutrons, and 11 electrons. So this is now the stable. How about if we're going to use isotopes, like for example, cation? Let's convert this one into cation. We have sodium 23, which has a 3 plus charge. Okay, let's take a look at the number of protons, neutrons, and electrons. If it is charged, if it is positive charge, positive 3. Okay, we have protons is equal to atomic number, neutrons is equal to, again, atomic mass minus atomic number. And how about the number of electrons? Okay, is equal to atomic number, okay, minus the charge, which is positive 3. Okay, so this is what? 11 minus 3, we have 8. Okay, we have 8 electrons. So as you can observe, okay, in a cation, it has more protons than electrons, simply because, again, this is positively charged. How about if we will convert this one into an anion or negatively charged sodium? Okay, so let's take a look at sodium 23 again. But it's different because we will charge it negatively to make it an ion. Okay, protons is equal to, again, the number, the atomic number. Neutrons is equal to the atomic mass, which is 23, minus the atomic number, which is 11. So we have 12. Okay, how about electrons? Electrons now become what? Atomic number minus the charge, which is negative 3. So it will become 11 plus 3. Okay, because these are all negative. So 11 plus 3, we have 14 electrons. So Since this is negatively charged, or this is considered as an ion, okay? An ion has more electrons than protons because this is negatively charged. As you can observe, protons is 11, neutrons is 12, but the electrons here is 14 simply because, again, it is negatively charged. Do you have any questions so far?
None.
Okay, why 12? 23 minus 11. Okay, 23 minus 11 is 12. The formula in actually extracting or getting your neutrons is the atomic mass minus the atomic number. That's why it's 12. Any other concerns, questions before we proceed to the electron configuration? Are you still with me? Okay, let's move now to the electron configuration. How can we get the electron configuration of a particular element? Okay. Let's have a brief recap of what we had discussed last meeting with electron configuration. Let me share my screen. Okay. Electron configuration, right? Okay. So this is now the layout of electron configuration. As you can see, SPDF is there. So we will create our own. Let me have the whiteboard with me. Right? Okay. Let's have the SPDF. Okay. One S, 2S, 3S, 4S, 5S, 6S, 7S. Sir, what are these? Okay. These are the what? These are the subshells. Okay. SPDF are your spin orbitals. Okay. Hang on. Okay. S, next is P. Okay, this is P, S, which actually can hold up to 2 electrons. How about the P? So let's start with 2P, 3P, 4P, 5P, 6P, and 7P. Okay, this is P, which can actually hold up to 6 electrons with 3, okay, orbitals, spin orbitals. Okay, how about D, SPD? Okay, let's start with 3D, 4D, 5D, 6D, and 7D. Okay, which can hold up to 10 electrons, and it has 5 spin orbitals. Okay, how about the F? Okay, let's start with 4F, 5F, 6F, and 7F, which can hold up to 14 electrons since it has 7 spin orbitals. Okay, SPDF. So let's start with this element. How can we get the electron configuration? Hang on, let me check on my periodic table. Let's have silicon. Okay, the atomic number of silicon is 14. So this is silicon is equal to 14. That's the atomic number of silicon. Okay, how can we get the number? How can we actually extract the electron configuration? This is the pattern. Okay, look at the pattern. Okay. This is important that you actually attend online classes because I will discuss this thoroughly. Okay. This will come out in your major exam, of course. This is included. Okay. And if there are some questions, please raise it directly. Okay. You can always ask questions even in the middle of discussions. We look at the pattern. It is diagonal. Okay. Can you see now the pattern? Sir, what are you doing? I am actually tracing the pattern in order for you to fully understand what we are actually doing here. Okay. And of course, the electron configuration will tell us about the location or the placement of our element. Okay. Let's have silicon 14, or silicon is actually has an atomic number of 14. So let's have this one. Okay. So let's start here. Okay. The movement is from here going there and there and there and there and there and so on. So let's have 1s. Okay. Hang on. Let's have 1s. And because because the s suborbital can hold up to 2 electrons, so this is 1s2. Okay. Next is, look at the movement. The second is 2s. Look at it from here going there. Okay. So here 2s. This is 2 s2. Okay. Next. Oh, okay. 2p. P can hold up to 6 electrons. So this is 2p6. Okay. Next is S. Okay, look at the pattern. From here, 1s2, 2s2, because S can hold up to 2 electrons. Next is 2p, this one, 6, because it can hold up to 6 electrons, followed by 3s. Okay, 3s. And how many electrons that S suborbital can hold? 2 electrons. Okay, so we have 2, 4 plus 6 is 10, plus 2 we have 12. So let's move. It's still locking. We are here, TS. Next is 3p. Okay, 3p. How many electrons that the p can hold? We have 6, but because we only lack 2 electrons here, remember, we need 14 electrons, right? So this is 2, 4. 4 plus 6 is 10, plus 2 is 12. So we need additional 2 electrons to make it complete. So this is 2p2 or 3p2. Okay. Let's take a look at this one if this is correct. Okay. This is the electron configuration of silicon. Okay, 1s2, 2s2, 2p6, 3s2, and 3p2. Okay, let's take a look at if this is correct. There are some placement. In order for us to identify, in order for us to double check on the electron configuration, all we have to do is to double check on the location of that particular element. It says here, this is 3p2. Let's take a look at silicon if it actually belongs to 3p2. Okay. Let me share the location. Let me share the layout of the elements. Okay. Hold on. Let me check on this. Again, in our illustration or in our whiteboard, it says it belongs to 3p2. 3p2, let me share this one. Can you see my shared screen? Are you still with me? Grade 8? Okay. It says 3p2. Okay, where is 3p? Okay, this is the 3p. Okay, this is the 3p. Let me annotate. Let me annotate. This is the 3p area. Okay, this is the entire 3p. Okay, this is 3p, right? But it says 3p2. So where's 3p2? This is 3p1 and this is 3p2. So the location of our silicon is in here. Supposed to be. Okay. Let me check on the periodic table if it is correct. Okay. Okay. 3p2. So our answer is correct. Silicon is in here. Okay. Silicon is actually here. Correct. Since this is P, 3P, right? This is 3P. So silicon is in 3P2. So this is 3P2. Right? Do you have any questions so far? We still have 4 minutes for you to ask questions in order for me to assist you. Do you have any question? Okay. Since you still have time, what I want you to do now is I want you to go to your LMS. Okay. Go to your LMS. Let me share your LMS. And answer activity number 2 that is completing the table. Okay. You are actually given tables there. This will end this 5 p.m. You're actually given tables. All you have to do is to check on the number of the atomic number, okay, the atomic mass. Check on the number of protons, neutrons, and electrons. And please also include the element notation. What is with the element notation? Just like what I did, okay? On the upper left corner of the element should be the atomic mass. In the lower left corner of the element, it should be the atomic number. So that is the element notation. How about the second part? The second part is cations and ions, your isotopes. So again, you need to calculate the number of protons, neutrons, and electrons based on the element or based on the cation and ion given or the isotopes given. Okay, this is worth 93 points all in all. Okay, again, these are concentrated activities. If you will not actually do your activity, it will give a big remark on your grade because these are concentrated activities. All right, do you have any questions so far? Questions so far? Grade 8? All right, I think that's all for today. I will expect answers from you until the end of the day. That's around 5 p.m. I'll be checking them one by one later. Okay, I think that's all for today, class. Have a nice day, grade 8. Take your lunch. Bye-bye.